Okay, so today we are going to take a look at section 2.1, inductive reasoning and conjecture, starting out chapter 2. So let's start off with a definition of a conjecture. When we make a conjecture, we're basically making an educated guess. And that educated guess is part of our inductive reasoning. So this is reasoning that uses a specific number of examples to arrive at a prediction. Sometimes you'll look for maybe patterns and so on. Okay, example number 1. Eric was driving his friends to school when his car suddenly stopped 2 blocks away from school. Make a list of conjectures that Eric can make as to why his car stopped. So think about it. What could be a conjecture as to why the car suddenly stopped? So think about it. If you want, go ahead and write some answers down. And none of these have to be correct. In other words, you can make whatever conjecture, reasonable conjecture. So I'll list some that I had from a previous year. Maybe the car ran out of gas. Maybe there was a flat tire. Maybe something happened to the engine. All right. Okay, let's take a look at example 2. The numbers represented below are called triangular numbers. Make a conjecture about the next triangular number. So we're looking here at patterns. So we go from 1 dot to 3 dots in kind of a triangular form, 3 to 6, 6 to 10, 10 to 15. Now I don't actually have to draw it out. I just want to make a conjecture about the actual triangular number. So take a minute, see if you can figure out that pattern. So it looks like if you see how we added 2 here, we added 3, added 4 to get 10, added 5. So that means the next number, so my conjecture is the next triangular number is 21. All right, let's take a look at example 3. So we're looking at the set of numbers, and we want to make a conjecture about the next item in the sequence. So we're looking at what is happening here. They're decreasing. And if we notice what's happening, subtracting 4, subtracting 5, subtracting 6, subtracting 7, subtracting 8. Therefore, what's the next number? Our conjecture is the next number is negative 19. Okay, then we have 2 goes to 4, and 12, and 48, 240, and then 1,400. So take a minute, see if you can come up with how are we getting each number in that sequence. And this is a multiplication, right? So if I look at, we're going to multiply by 2 to get 4, multiply by 3, multiply by 4, and so on, which means our next number is going to be 10,080. Let's go to page 2. And here's the other big part of this lesson. So one is making conjectures, and then the other part is establishing whether that conjecture is going to be true or false. So sometimes we can make a conjecture, but that conjecture is not always going to be true. And that is where we come up with a counterexample. So what I have stated here, conjecture based on several observations may be true, but false in others. It takes only one false example, called a counterexample, to show, so basically we're showing that a conjecture is not true. In order for a conjecture to be true, it must be true in all cases. So a counterexample can be written out in detailed words, or you can make a detailed drawing. I want to make sure it's labeled, and I want to be specific. Okay, so here's our first example. Determine whether each conjecture is true or false. Give a counterexample for any false conjecture. So given, okay, so basically this is the part that has to be provided. So this is already true. Like basically this is known. Angle 1 and angle 2 are supplementary angles. So the conjecture is angle 1 and angle 2 are both right angles. So we're asking ourselves, must this be true? Okay, so if you have two angles that are supplementary, do they have to be both right angles? And hopefully we're thinking, no, that does not have to be true. So now we want to give a counterexample, and we want to be specific. Notice I had names for the angles. I have angle 1 and angle 2. So I want to show supplementary angles. Okay, so I want to make that part true, but I want to draw it so that I don't have right angles. So here's what I'm going to do. I'm going to draw a line. I'm going to make a linear pair, and I'm going to draw a ray. And there's multiple ways to do this. Okay, so there's more than one way to draw a counterexample. So what I can do is I can say here's angle 1 and here's angle 2, and maybe I want to say angle 1 is 120 degrees, angle 2 is 60 degrees. That way I can see, are these supplementary? Is the first part true? Yes. And did I show a picture where the conjecture is false? Yes, I drew them so that they weren't right angles. Now another way I could write this out, remember I said you could do a detailed drawing, which is what we did, or we can actually just write it out in detailed words or symbols. So I could just say measure of angle 1 equals 120, and I could say measure of angle 2 equals 60. So did I state two angles that are supplementary? Yeah, they add up to 180. And can we clearly see that these are not right angles? Sure, they're 90, they're not 90 degrees. So this is an example of a drawing. This is how we would write it out in words / symbols. And both are correct. You don't have to do both things. I'm just telling you that you can write it out either way. Okay, points A, B, and C are collinear. The conjecture is B is between A and C. So let's think about that. So if we have collinear points, all we know is they're collinear, they're on the same line. Must this be true? Does B have to be between A and C in order for all three to be collinear? No. So now we want to draw three collinear points. So I'll draw a line. I'll put 3 points. But I specifically want the conjecture to be false. So I don't want B to be between A and C. So maybe I'll put B here, A here, and C here. And that's my counterexample. And I forgot to state, sorry, we did not go back and say, so this one was false. So here's my counterexample. And this one was also false. So my counterexample is this drawing. Okay, given. So n is a negative number. N is a negative number. The conjecture is n squared is a non-negative number. So we want to think, is that always true? Could we prove it false? So if n is negative, does n squared must be a non-negative number? Well, hopefully we remember if you square a negative, right, it's going to be positive. So which is non-negative. So actually this one is true. And if it's true, we just leave it that way. You don't need to do a counterexample, and you don't have to write out any kind of proof for it. Okay, so you are going to go and continue the lesson with a Pear Deck presentation. So you will find a link for that under your assignments, and you're going to work on that also for the rest of the period. And if you finish everything early, then you can start the homework.